Hello fans of GeoGebra. We have an L-shaped roof here. We're looking at it in plan view. There are some loads hitting it. Perhaps they're wind loads that were uniformly distributed along the north face, but now they're concentrated at the centroid of the north face. 750 going pure south, and then maybe another wind on this facade. Uniformly distributed. We put it at the centroid, and let's say it's 1,000 units of force. I have three reactions. I don't know whether they're going up north or south here in this corner, or north or south in this corner, or east or west in this corner, but I have three equilibrating lateral force resisting systems. You could recreate this at home by copying the grids here: 5-unit spacing east-west, 6 units of length spacing north-south. What do we do first? Well, we perturb the system. Let's find the sole reaction. There is always going to be, in these determinate cases, one equilibrating force that is alone. And obviously that has to be 1,000, but let's just walk through really quickly. We perturb the system. We follow how much energy is, or how much work is done by each of the loads, the external loads. So the west load would move 1 positively. The wind blowing here on the north wall going south doesn't do any work for this perturbation. And this one is going negative. So the signs switch, and then we divide by the loft, and we get that reaction to be 1,000. Easy peasy. Okay, next is the construction of the rigid roof. I'll just show this to you really quickly. It's a linkage as before. I lofted up the southeast corner because I'm looking for the southeast reaction. My first step was to draw this circle, which is the radius of the wall here on the south. And I intersected it with this horizontal line because I know I had a reaction here, but I don't think you have to do that. But it's nice, nice way to start. And then from that point, I went the length of this first west wall and found where that is. And then I built up slowly more and more with other perpendicular lines, and then I came back to this vertical line here, but it fits perfectly anyway, and you'll see what I mean when you do this on GeoGebra. The loft, once again, is arbitrary. You could loft it as much as you want just for the visuals. The nice thing here, I think this is pretty sweet, is that you could see the work done by the west force. What it really is this force times the westward movement, and I'm calling it left-east because it's on the east face. The work done by this force, the wind blowing southwards on the north face, is this loft, and that one is positive, this one is positive. The work of the known reaction here is negative. You could see that. It's this number here, super easy to find. And then the internal work of the southeast is just that force times the loft. So then we divide through by the loft, and we get the answer here, which is supposed to be 300 by theory. And we're going to break that down, 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 down. And we're going to get 300. This one's a little unstable because I think this load, shoots right through this one. I just made this up, so it's kind of fussy. But anyway, it's asymptotically approaching 300. Super cool.